Hello everyone, myself Halesh Amar. I am working as an assistant professor in the EC department, Sri Jayachamrajendra College of Engineering, which is a constant college of JSS Science and Technology University, JSS Mahavidyapita, Mysore. Okay, so I'm going to discuss about the subject analog electronic circuits, which is for the third semester, and this is for the 2022 curriculum. So the third semester analog electronic circuits with the subject code 22EC330, and this is 2020 curriculum, which is a 40-60 scheme. That is, internal evaluation will be done for 40 marks and external semester and exam will be conducted for 60 marks. Okay, so which constitutes a total marks of 100. That is how this will be evaluated. So now coming to the syllabus part of it, I'll just brief about the syllabus. This is the syllabus of analog electronic circuits which you are going to study for this academic semester. Those who have admitted for 2022 academic year 22-23. So by the end of your second semester, you might have already earned a total credit of uh, yeah, you have earned a total credit of 40, and this semester, in the third semester, you will be earning about 25 credits. Okay, for this analog electronic circuits will be for 4 credits, which is an integrated subject. Okay, so integrated subject means you have a theoretical class of 3 hours per week, which constitute to 39 hours for the total complete semester, and 1 practicals per week, which constitute to 20 hours or 10 lab sessions, 10 to 12 lab sessions per semester. Okay, so the prerequisite for this subject or this course is elements of electronics engineers, which you have studied in your first or second semester, and the objective of this subject is to introduce analog electronic concepts such as frequency response, feedback, stability and compensation, and also to develop ability to analyze and design analog electronic circuits using some simulation tools. So this is the main objective to study this course, and these are the course outcome. I will brief about this course outcome. Before that, I will just mention about the content of the syllabus. The content of the syllabus includes 5 unit, among which it is constituted to a total of 39 hours for the entire semester. So in the first unit we will be discussing about BJT amplifier circuits. You are going to study about the DC analysis and AC analysis of the BJT circuit as an amplifier in a 3 different configuration, that is common emitter, common base and common collector configuration as an amplifier circuit. So the same thing you are going to repeat it for the MOS device also, which is a MOSFET. You are going to analyze a DC analysis and also the AC analysis, which is basically a small signal model for the MOS amplifiers. Again, a 3 different configuration: common source, common gate and common drain amplifiers. So these are the 2 devices which you are going to study independently in this course on the first and second unit, and then in the third unit you are going to read about the frequency response. What are the frequency response, low frequency, high frequency behavior of both BJT as well as MOSFET device, right? So the frequency analysis of both the devices as an amplifier you are going to analyze here. And one of the important application, which is basically a feedback amplifiers and oscillators, taking an example, is the important application which you are going to analyze here with certain concept, feedback concepts, topologies and so on, by making use of these AC and DC analysis and the frequency response what you have studied for the BJT and MOSFET device. Okay, and the last unit is of output stage and power amplifier, which you will be studying about different types of power amplifiers with a different configuration. Okay, so the textbook for this subject is Cedra and Smith, which is titled Microelectronic Circuits 7th or 8th edition. and the reference book is Robert Boylsted, Electronic Devices and Circuit Theory, so the 11th edition, and Millman and Hykins, Electronic Devices and Circuits. And this is UB Mahadev Swami, as you know, our current HOD. So this is the book written by our HOD UB Mahadev Swami, entitled Analog Electronic Circuits, in 2010, revised in the 2010. Okay, so as I told, this is an integrated subject. This is an integrated subject which includes a theory as well as practical. So the practical content of this subject, analog electronic circuits, includes clippers and clamper circuit, rectifiers, VI input output characteristics of BJT and MOSFET, and one of the application which is RC coupled amplifier, high pass low pass filter. So BJT Darlington emitter follower, feedback circuit, oscillators, and completed with one of the test. Okay, so this is the content of the syllabus, to give a brief introduction about this. So by the end of this, the outcome, or what you're going to, or the completing this course, the students will be able to explain the working principle of various analog electronic circuits and explore their application. As I told, the working of analog electronic circuits like an amplifiers making use of BJT or MOSFET, you're going to understand the concept behind that and explore those applications for these analog electronic circuits. And the second outcome is analyze the important relations for analog electronic circuits. Analog electronic circuits here is basically the amplifier circuits which is designed by BJT and MOSFET. So analyzing the important relations, there are certain performance parameters, what you can say, performance parameters of these amplifier circuits. You need to analyze that and you should be able to interpret the results. Okay, and the third CO, the course outcome, is to apply the concept of analog electronic to design amplifiers and oscillators. Basically, the purpose of mentioning this is by making use of this BJT and MOSFET, the DC and AC analysis, what you have studied, understood, and able to analyze that, you should be able to design it for the higher application. That is what you're going to do it for your the third outcome, which you are going to do it for oscillators and feedback circuits kind of thing. And the fourth CO is generally for the lab component. What you have mentioned here is to construct, simulate analog electronic circuit, demonstrate their working practically in the lab sessions, and compare the practical result with the theoretical design value. Okay, you have a simulation tool using which you can understand the circuits, and you can also demonstrate the same in your lab practicals and then you can able to compare and interpret the results between the theoretical, the practical what you have done, and the simulations what you have got. Okay, so this is the course outcome of the subject. Brief introduction about the syllabus as well. Okay, so this is a core course which is of 4 credits, 3 credits for theoretical part lecture and 1 credit for practical. So total 4 credits. So in the entire semester you will be studying it for 59 hours including theory and practical. Okay, as I told, this is an integrated subject. So integrated subject means, so let me tell you about the calendar of event. The calendar of event which will be distributed across the semester. So this calendar of event, the beginning your semester will commence from 2nd November and semester will get end by 27th February. This is the semester working hours from 2nd November to 27th February. So during this period, so your subject will be evaluated, continuous internal evaluation, into 3 events. Okay, the 3 events, among which the 2 events are test which is done at the college level, and the second unit, the second event will be dependent on the faculty at the department level itself. Since this is an integrated subject, we are taking a lab component for the evaluation of event 2. Okay, so as I mentioned, this scheme is 40-60. The internal continuous internal evaluation will be for 40 marks and external will be for, semester end exam will be for 60 marks. Now how will they evaluate this 40 marks internally, right? So as I told, you have 3 events, the 2 tests which will be conducted for 30 marks each, and then it will be reduced to 15, and lab component which will be conducted for 20, and again that will also be reduced to 10, so that a total CIE what we evaluate here for 80 marks and reduce it to 40 or 50% of this, right? So the test will be conducted every 6th and 13th week of the semester as per the procedure in the calendar of event, right? And then a student must score an average of 50%, that is 20 marks out of 40 from all the events 1, 2 and 3 to gain eligibility to appear for semester end examination. Along with this, you should have a minimum attendance requirements which is 85%. Okay, so you need to make sure that these 2 criteria are satisfied to appear for the semester end examination, right? And the semester end examination will be conducted for 100 marks and that will be reduced to 60 as I told. So external or the semester end examination will be conducted for 100 marks and then it will be reduced to 60. Okay, so 40 is the passing marks for 100, and for 60 you must score a minimum of 24 or 25 out of 60 in the semester end examination. Okay, so however, for passing this subject or the course, the student has to score a minimum of 45 marks out of 100, that is internal CIE minimum 20 out of 40, external SEE minimum 25 out of 60. Okay, minimum 25 out of 60. So 25 plus 20, 45, or 21 plus 24, 45. Okay, the 45 is the minimum marks to pass this course, to clear this course. And here you need to make sure that to appear for the SEE you should have a minimum of 20 or 21 internal CIE. So if you don't have this minimum marks, which is a 20 marks out of 40 among the 3 events 1, 2 and 3, you will not be able to eligible for SEE. Okay, so even though if you get less marks here, 18 or less than 15 or something like that, you will not be able to take the semester end examination, so that you will not be able to clear the course. So minimum internal CIE should be 20 and minimum SEE should be 24. Otherwise, even though if you get internal CIE 20 or 21, and even if you score in the semester end examination less than 24, you will not be able to clear this course. Understood? So this is about the theory part and the examination part of it. Okay, and the lab, what I told, each lab will be evaluated for 20 marks. You see, these are the experiments what I have mentioned: clippers and clampers, rectifiers, BJT characteristics, MOSFET characteristics, amplifier circuits, and then feedback circuit, oscillators, right? So here each lab will be evaluated for your preparedness. You should come prepared for the lab. Conduction, viva, result interpretation. I mean, after you get the result in the lab, how you are going to interpret the result, what are the things that you have understood, and then writing your records, or basically report writing. Okay, so each parameters carries a marks over here, which is 4, and total evaluation is 20 marks, so that each experiment which you are doing it for each lab will be evaluated for 20 marks. And finally, it is average marks of all the experiments are reduced to 10, taking it for evaluating it for 20 and then reducing it to 10, taking the average and then reducing it to half of it, that is 10. And then we have another event at the end of the lab, which you will be conducting a test for 20 marks, and then that will also be reduced or finalized to 10 marks. So your final CIE for event 2, which is supposed to be for 10 marks, will be taken by average of this event 1 and event 2, means this E1 and E2 parameter over here, and this will contributes 10 marks for your event 2. Okay, and then you will be having a test which will be conducted for 75 minutes. So each test will be conducted for 75 minutes, 30 marks, and that will be reduced to 15. So 15 plus 10 plus 15, 40. Okay, so that will be how the internal CIE for 40 will be evaluated. Okay, so this is how the integrated subject will be evaluated, and this will be distributed among the calendar of events. The scheme and syllabus for this you can get it from the website here itself in the JSS Science and JSSSTUNIV.in for the ECE department. So this is our HOD, what I mentioned, UB Mahadev Swami, and he has written a book on analog electronic circuits, which I mentioned in the third reference of my syllabus. Okay, and the remaining part, this is the vision of the department, mission of the department. So vision of the department is to be a leader in providing globally acceptable education in electronics and communication engineering with emphasis on fundamentals to application, creative thinking, research and career building. This is the vision of the department, and the mission of the department, you see, to provide best infrastructure and up-to-date curriculum with good learning environment, enable students to keep pace with the emerging trends in the industries which is related to the ENC, electronics and communication engineering, and we encourage all the students for strong participating across different industry as well as student entrepreneurship, and to promote, this is the most important, promote socially relevant eco-friendly technologies and inculcate innovative activities in the department. Okay, so for more information about the department, you can go through the website where you can get the some of the important information related to your scheme and syllabus. So for the different curriculum, this is your 2022 curriculum, and you will get your timetable along with the allotted rooms as well, right, and calendar of events as well. This is how you can fetch the information related to the scheme, syllabus, calendar of event, timetable and all those things in your website as well, right. So this is the brief introduction about the syllabus along with the content and the activity what you're going to do in the semester for this entire semester, content and how they are evaluated and corresponding to your evaluation for internal and external SEE, okay, for this subject. Okay, so this is about the introduction about the syllabus and then some of the course outcomes of the subject. I hope you will get certain information or idea about what you're going to study in the current semester. Okay, so with this I will end up this video, and in the next class we will start with the syllabus. Okay, thank you.